Forging may be defined as a metal working process by which metals and alloys are plastically deformed or reduced to the desired shape by the application of a compressive force. Forging can be done both hot or cold. However, forging is always misunderstood to be hot working only. However, forging can be done in ambient temperature as well. It differs from rolling process, which also employs compressive force to deform the metal. In forging, the pressure is applied intermittently instead of continuous pressure as in rolling. The products of forging are generally discrete pieces rather than a flowing mass as in rolling. Now, the forging process is superior to other metal forming process and other manufacturing processes. The reason behind that is the forged components have comparatively high strength to weight ratio. The reason of high strength to weight ratio of forged part is that they have fibrous structure and the grain structure or the flow lines of the metal are not interrupted but are made to follow the contour of the forged part. The main objective of good forging design is to control the lines of metal grain flow so that a part with greatest strength and resistance of fracture is produced. This can be understood by taking an example where a same part is produced using casting, machining and forging, as you can see in this particular figure. Here, a similar part is being made by three processes, that is casting, machining and forging. Let's say it's a crankshaft. The crankshaft produced by casting has no grain flow and so has the poorest mechanical properties. The next figure here depicts the same crankshaft made by machining. Here, as you can see, the fiber of the metal is getting interrupted in between, and hence the mechanical properties of the crankshaft will be poorer than those of the crankshaft made by forging. Here, the fiber of the metal has not been interrupted and continues along the entire length of the shaft.